In this demonstration, I'll be giving you an overview of the new Sage X3 web scheduler. This demo is using data from the food and beverage industry, a business that is producing dried pasta. On the left, you can see the plant set up in this plan. The production Gantt view is a key aspect of web scheduling and allows the planner to easily focus and understand if the plan is optimized. If required, the planner can make changes to the plan and production sequence for each line to be produced in the plant. In the resource area, you can see details of all the production lines in the plant that are to be scheduled by the planner. Web scheduling allows you to create partitions of your plan by department or production line, so your plan can be managed by multiple planner users in different departments or responsible for different areas. Across the top, you can see the calendar, which can be viewed by days, which is the default, or by an hourly view. The interface also lets you zoom in or out of the plan. In this example, you can see we have a variety of operations, some with long timescales and others that may have very short timescales. Web scheduling provides many features to ensure that the planner can easily understand what is happening in each specific area. The colored bars are the operations sequenced in each line. The background color is the first indicator of characteristics such as product type or operation status that helps the planner understand what has happened on a line. In this example, the color is set to indicate the shape of the product. If the shape needs to be changed for a line, then there will be a lot of time-consuming setup to the equipment. To manage this, heuristics have been set up, and the color quickly identifies when the shape has to be changed. We have something that isn't optimized as we are passing from green to orange, then back to green. It would be best to move this green item up. We refer to this movement as manual forcing. And note, you can always rerun the automatic algorithm and specify if this should consider the manual forcing or not. Web scheduling is operating in real time as it has two different algorithms, one that allows you to rerun the automatic schedule taking into account the manual forcing, and two, where web scheduling automatically checks and recalculates the plan. There is a real-time engine that runs every time I move something and checks the rules based on my plan. For example, if I select this yellow item and start to move it, the system shows me in dark blue where I have available resources for this item. So if I move it to the top line, you can see that first of all, it has become bigger as the cycle time of line 1 is slower than the previous line. A new icon, a wrench or a spanner, has also appeared in the bar. This tells me that I have problems to address, but I'm just previewing possibilities as I'm moving around. So let's choose to drop it here and confirm the operation. To help me analyze any issues, I can go to the Tool Trend tab to review where I might have a problem with tools. The fishing pond shows us a complete set of all operations that are available for scheduling, including those that have been fully scheduled, partially scheduled, not scheduled, or are already produced and closed. You can easily apply filters on any of the columns, and you can also tailor your view and manage which columns you want to appear in the list. When you select an item in the fishing pond, you can see that it automatically focuses the Gantt view to display your selected item. You can click on that operation to both view and manage activity details such as order details, production information, identify material constraints, as well as team and tool information. As I look at this item and move to the production information, I can see that this item is completed or partially completed. I can also see resource information, duration details, and scheduling data, including, if relevant, alternate resource information. Calendars, shifts, and exceptions. This calendar is defined in a hierarchy. First, we define the plan calendar, then, by exception, the department calendar, and so on down to a particular machine. The same process is used when defining available time. For example, if I'm planning and scheduling for today and I have information coming from my ERP system related to the product line or related to a breakdown on the machine. If there is a machine breakdown, the scheduler is notified and the bell indicator turns white. I can see the details to understand the impact of the breakdown. Each line of the production Gantt represents a resource, and you can customize the information shown in the resource bar. For example, you can choose to see order number, material name, field description, packaging, and so on. During any manual operations in the production Gantt, the system dynamically checks in real time the constraints of materials, working shifts, and tooling. So for example, if I move this item, the system automatically calculates that I would need more tools available than I have in my plant, and the tool indicator automatically appears to alert me. I can also set up condition color rules based on the operation or materials availability date constraint. For example, the blue bar indicates the setup time required. This operation requires no setup time, but this one requires 15 minutes setup time, for example. The resource Gantt lets you view line by line details of the operations and downtimes for a resource selected in the production Gantt. This is important when you have a machine that can produce more than one operation in the same time period. The resource Gantt allows you to see details in a grid view and also as a Gantt chart. The resource Gantt displays line-by-line work orders and downtimes for the resource selected and production Gantt. So you can also configure color rules for the resource Gantt. Here it is configured to display in green if the operation is on time and red if an operation is delayed. Moving operations, single and multiple. I can move operations by dragging and dropping from the main production Gantt, or I can cut and paste from the resource Gantt, which is easier if I want to select and move a very short operation. If I want to move multiple operations and place them in a different bucket in the same resource or to another resource, I simply select the lines. For example, if I want to move these items all related to the same operation, I simply select them and cut which places them in a virtual chart. I can view the virtual chart and see the items and also see the machines where I could move them to. I can see that they could all be moved to line 5. So if I go to line 5, I see that I have a gap after the first operation. So I simply select either to paste before or paste after, and web scheduling performs the movement. Web scheduling recalculates any constraints for the moved operations and also recalculates any constraints on the original line. Adding constraints. Web scheduling allows you to set up constraints in your plan. For example, in line 8, I'm okay with a sequence until this operation. By clicking on this last operation in the sequence, I can force a set priority sequence. You can see the sequence on each operation and the production Gantt item is highlighted. If I rerun my plan, it will take into account my selection and produce exactly this sequence. If, as a result, I don't have the required tools on a particular date and I rerun the plan, web scheduling will leave my items in line 8 and move the other items to another line. Choosing rules. To provide you with the flexibility you need, web scheduling allows you to manage the scheduling settings that will be applied during the automatic scheduling process. You can enable or disable items such as tools that will adjust the heuristics applied during automatic scheduling, and areas like material management where you can set the system so that it will take into account the availability of materials at a specified date. Changing the horizon. In addition to the previous rules, you can adjust the horizon by changing the automatic scheduling days. You can also apply a frozen period, which means that any operations scheduled before this period will not be changed by the automatic scheduler. Drag and drop. As well as the automatic scheduling settings, you can configure the system behavior during manual drag and drop operations. For example, if you enable push right, Then you drag an operation over the start date of another operation. The plan is automatically pushed forward to free the space needed to insert the dragged operation. And finally, multi-simulation. Within an editing session, you can create copies of the production plan to support what-if analysis of your plan to help drive optimal performance. Using the multi-simulation functionality, you can create a copy of your master plan. The copy is an exact replica of the master, and it allows you to make configuration changes and compare these with the master so you can determine which would be the best option to take. Once you have performed your what-if analysis, you can commit the chosen simulation, which will then become your new published master production plan. Thank you.